Hello everybody, quick video on my gas tank plate. As you can see, I have a manometer set up. So this is the best way the van says to test it. So you have your Schrader valve here, your plastic tubing here, and it runs down. You can see, so I marked 14 inches, and then when I put air into the tube, I marked, so if this on this side is even with this, which it was, then... Okay everybody, this is the part of the video where I have to splice out some of my other video because I essentially had bad information in it. So my wonderful wife, who is clearly the brains of this operation, has done the math and shown me the error in my ways, as she usually does. So I will let you explain the math here.
Okay, so basically you have air on this side, you've got air here from the tank, and then in between is water. All in here.
Yep.
And Bernoulli's equation compares the pressure on this side, which is atmospheric pressure, with the pressure in your tank, and you obviously have to have more pressure in your tank in order to push the fluid away from the tank. Okay. And so, in using Bernoulli's equation, we have no movement, and so both of the velocity terms are zero, and so what we're left with is a pressure term and an elevation term on both sides. And so when we eliminate the velocity terms, we end up with that the pressure in the tank plus the elevation on the tank side of the water is equal to the pressure outside, with some alterations, plus the elevation of the top of the water. And so if we switch the pressure terms over and the elevation terms over, we're left with that basically the difference between the pressure in the tank and the pressure outside the tank, those terms is going to be equivalent to the difference in heights of the water. And so we established that if you raise the height on this side from its initial point, if you raise it 27 inches, so if it initially started here and it was level over here and you raise it 27 inches, then you've effectively created a height difference of 54 inches. And so we can set the height terms equal to 54 inches. Yeah. And then the pressure term, we can eliminate pressure too, because we're talking about the differential pressure across the wall of the tank. So we have P0 out here, or we have P2 out here, sorry. We have P2 out here and P1 in the tank. And so it doesn't matter what the atmospheric pressure is. We can just call it zero because we're looking for what is this that's more than what's outside. And so we can eliminate the P2 term. So what's left is the P1 term and the constant underneath here that makes it basically a height measurement is gamma, which is the unit weight of the water, or the sort of the density. Okay. When you set that equal to the 54-inch height difference, and then you move gamma over to the other side, you get that the pressure inside your tank is equal to the height difference of 54 inches times gamma. And gamma at 85 degrees Fahrenheit is about 62.2 pounds per cubic foot. Convert cubic feet to cubic inches, and you get that the pressure inside your tank was 1.94 psi.
So as we figured out, because my interpretation was that you set level and level, and then you move this column up 27 inches. That was my interpretation of the van's instructions, which clearly was wrong.
And I understood in the moment that what we needed was a difference of 27, but my brain did whatever it did and what we ended up doing was marking and then going up 27, which I guess I was just not accounting for this side.
Exactly. So essentially you need a 13.5 inch drop here and a 13.5 inch rise here for a total
or you need a manometer tube that hangs closer together, because ours hung too far apart because
Right.
the tank was too far onto the build table.
Yep.
Which is why I was saying that it would be helpful if we could move the tank closer to the edge of the build table before it was clamped on.
Exactly.
Because you want the manometer tube, instead of being hung wide like this, you want it to form a much tighter U, so that you can physically measure, okay, the fluid's here on this side and here on this side, and that difference is 27 inches.
Gotcha. Yep.
And that's why I hung a weight right here to try to make it more of that shape. But we still had too much horizontal distance between the tank and where the tube was hung at the top.
Right.
To be able to measure straight across easily.
That, along with my bad interpretation of it's not 27 from level going up this way, it's 13.5 drop here, 13.5 rise here,
And,
created a situation where we then had almost 2 psi in the tank.
Right.
And that's why my gas caps were leaking air all the time, was because if we had half of that psi, they probably would have held, and I wouldn't have had to go through that saga.
And ultimately, for anyone who's trying to figure this out in the future, basically it's this number right here that we really want this number to be 27.
Yeah.
We want H to be 27, which is the difference between the heights of the water on both sides of the tube.
Nice. Thanks.
No problem.
So then I keep running into this issue, and I don't know, I mean, you can see how many times here I've made up this packing tape thing that they say to do. And as you can see, the bubbles keep just finding their way out somehow. One of them, it was out through this side, one of them is out through this side. I don't know what else I'm gonna do to seal up this gas tank, because I've taken the gas tank off, I've tightened it to where it seals as best as I can get it to. I even put a very small smear of axle lubricant around it, and that slowed the progression of air out of here. But it's still, as I'll show you with my spray bottle here, as you can see, the bubbles are growing. Yep. So I'm at a loss as to how exactly I'm gonna get this thing sealed up, but one way or another, I'll figure out a way. Okay, everybody, here is the state of my manometer exactly 12 hours after I started. This is my baseline. As you can see, I have this dot right here with GT on it, meaning Gorilla Tape, and as you can see, it has dropped. I don't know. I've yet to actually measure how much, so let's see here. 7-ish, little over 7 inches. So, of course, first place I went to, you guessed it, and let's see if we can get it to do it. Okay, update number 4. As you saw in the last video, I was trying to find the leak and I couldn't. So I had to put my manometer back up close to my original to know that I do, in fact, have 1 PSI sitting in this tank. And here it is. With 1 PSI sitting in the tank, the slowest possible leak known to man has come back. And once again, it all hinges around the gas cap. I am pretty much ready to just call it quits and say I have a sealed tank, because this gas cap is going to be the death of me. Okay, here we are, tank number 2. This one technically being the left tank. As you can see, still working with the only thing I know, which is Gorilla Tape. And I didn't expect it to hold. And of course, 12 hours later, it's holding exactly where I had it. So this Gorilla Tape does work. I just have to figure out how to make it hold on the right tank now. So onwards, upwards, but all right, captain's log number, I don't know, 18. I can't remember how many of these I've done now. Woke up this morning. It started here last night. It's down to here now. I obviously have a leak. I figured it was my fuel cap like it was before. It wasn't, so that sucked. And then I found the leak. Ugh. That sucks. But on the bright side, at least it's maybe fixable. Should actually quite be easily fixable. Just get along there. Which I think is the same thing that happened to Trent, which is really weird that people keep seeing it show up there. And while I was on the phone a couple of days ago to Van's tech support, they were saying that most people are seeing something along here or in these corners here. So, yeah, math checks out, but man, does it suck to have a leak. Ugh. But at least it's a fixable leak. Okay, everybody, hopefully this is the final video. This is my manometer that I set up last night. Come on, baby, focus. There she is. So this is where it was last night. It dropped down to here where the dots are. I have had some air in the line, which you can see here. So considering that I had air in the line, I just redrew the line. And sure enough, this was a drop from 7 hours. So at 7 hours, I drew these dots. And then it went up this much in 7 hours, which makes sense because it has been getting hot in this garage. So I'm pretty much calling it that she's holding. I'm gonna give it another 24, 48 hours, but I decided to make the video now. So this is my fix here, and I'm painting, so that's why I have a blue glove on. But anyways, this is my fix here. So you can see where I smeared some on the outside, but I did take this fuel sender off. And I ran my finger with some Pro Seal along here. I was incredibly fortunate that it was just here, which brings me to my final thoughts of fuel tank building. And this only hit me after the fact, so hopefully this helps somebody. If I were to put the rear seal on again, I would do what I think I accidentally did correctly last time, which is as I slide the back baffle onto the tank, I had about 1/4 of an inch overlap on this side. So it was hanging off about this much, which means that whenever I went to go slide it on, I put it on and then I had to shift it a little bit this way, which means that on the other side over here, essentially this was 1/4 of an inch that way. And so then when I had to shift it, it went this way, and it took the big bead that I had along here and kind of smeared it across. Because the last thing you want is a leak over on this side. A leak over here, thankfully, isn't too hard to fix because you can get into it here. A leak on the other side, you're drilling holes in your tank. So if I ever make tanks again, 1/8, 1/4 of an inch, something like that on this side, so that if a leak does present itself, it's at least over here where I can fix it and not over there where I can't. That would be horrendous. My second final thought, this stuff,
kids' bubble, for like blowing bubbles outside. Because it took me forever to find this leak. I used dish soap all over this tank. I mean, I was going every single rivet, just doing dish soap. I did every nook and cranny, everywhere. I did all of these baffles back here and in front of here, and I never found this leak here. This is the only thing that found it, and it was because the leak was so horribly slow that it just was not presenting itself with just normal dish soap. You needed something that was actually going to attach and make bubbles. So making bubbles. Third thought is, again, the leak was so slow that the only thing that was going to show it was a manometer test. I put out there online, hey, my balloon stayed inflated, for an entire 2 days. So I've got sealed tanks. And there were a whole bunch of people that said, you may or you may not, but the best way to find out is a manometer test. And they were absolutely right. It would have never presented itself. It's such a finite measuring test that it allows you to see really whether or not you have a leak. So yeah, hopefully those tips and tricks helps somebody out there. I know everybody online sure helped me, because I would have never found this until I put fuel in it, and then I would have been really upset. That would have sucked. Anyways, take care.